In this presentation, we will move through a clear structure that includes the motivation for focusing on RTTA, what RTTA represents, and why comparing these specific LLMs matters for users and enterprises. We will then cover the experimental design and workload structures, detail the measurement approach to ensure accurate benchmarking, and present a results snapshot with insights. This will be followed by a deeper analysis of the architectural differences driving RTTA variance, recommendations for practical deployment decisions, and a conclusion summarizing our findings. The motivation behind this benchmarking study lies in the widespread adoption of large language models for real-world tasks and the observed impact that latency has on user satisfaction, developer productivity, and the effectiveness of automated workflows. While many studies focus on accuracy or cost, RTTA plays a significant role in day-to-day user interactions, particularly for conversational agents and live API integrations. Claude, ChatGPT-4o, and Gemini each have unique architectural characteristics worth benchmarking. Claude emphasizes stability and structured outputs with batch processing, which suits use cases where consistent and thorough responses are needed. ChatGPT-4o introduces streaming output, providing immediate partial results while the full answer is generated, offering a smoother user experience in interactive sessions. Gemini, with its real-time web crawling for factual retrieval, aims to deliver the most up-to-date information, but introduces potential delays due to retrieval and parsing steps. Experimental design involved constructing a balanced and structured benchmarking process using 25 practical diverse workloads reflecting common and advanced user queries. These workloads cover a wide range of domains, including technical Q&A, infrastructure design, code generation, translation tasks, and retrieval-augmented generation scenarios. This design ensures that the benchmarking results are relevant for various enterprise scenarios and that the differences in RTTA across models are highlighted accurately. The workload composition is essential for meaningful RTTA benchmarking. We included prompts that stress different aspects of LLMs. Highly technical queries such as CUDA usage, file system explanations, and HPC infrastructure planning, language translation tasks to measure multilingual performance, and advanced use cases like generating business analysis and performing RAG tasks. By covering these diverse use cases, the workloads reflect realistic enterprise tasks while capturing the architectural differences in how each large language model processes them. The workload design focused on balancing prompt complexity, ensuring consistent structure across models, and including both single-step and multi-stage reasoning tasks. This allows us to evaluate how each model handles structured data requests, open-ended questions, and multi-step tasks that require chaining reasoning. By maintaining consistent prompt structures, we reduce the possibility of prompt engineering skewing the results and ensure that comparisons are fair and replicable. Our measurement approach focused on practical realism by using manual stopwatch timing. The timer started immediately upon prompt submission and ended when the final token was rendered on the interface, capturing total perceived latency. This method is reflective of actual user experience, which can differ from back-end latency reported by API metrics. This approach ensures that latency introduced by model processing, streaming behaviors, and, in Gemini's case, real-time retrieval are all captured in the RTTA values. We employed a robust measurement strategy to ensure data reliability, repeating each workload 3 times per model across different times and stable network environments. Using Claude as the baseline allows us to compute relative RTTA ratios, making it easier to understand the comparative speed advantages of ChatGPT-4o and Gemini. This strategy accounts for variability due to prompt processing and temporary server or network fluctuations, ensuring that the results are consistent and meaningful for deployment decisions. We included a detailed workload-by-workload RTTA table that highlights the performance of each LLM across the 25 test prompts. This table provides clarity on which tasks each model excels at and where performance bottlenecks occur. By visualizing these data points, teams can assess which LLM aligns with their workload needs, considering not just average speed, but workload-specific behavior that can impact workflow productivity. The result snapshot shows that ChatGPT-4o achieves an average RTTA improvement of 1.09 times faster than Claude, while Gemini averages 1.12 times faster. However, the results also highlight significant variance across workloads, illustrating that Gemini shows exceptional speed in retrieval-heavy workloads but lags on translation tasks due to crawling delays. ChatGPT-4o shows consistent latency reductions across all prompt types, which is beneficial for environments requiring predictable interaction speeds. This shows the results summary table. Architectural insights are key to interpreting the benchmarking results. Claude's batch processing and structured output generation make it reliable but can increase latency. ChatGPT-4o's streaming architecture reduces perceived latency by allowing partial results to flow as they are generated, ideal for interactive and chat-based use cases. Gemini's real-time retrieval architecture enables up-to-date factual information, but can introduce significant variability in latency due to dependency on live web data retrieval and processing delays. Architectural insights are key to interpreting the benchmarking results. Claude's batch processing and structured output generation make it reliable but can increase latency. ChatGPT-4o's streaming architecture reduces perceived latency by allowing partial results to flow as they are generated, ideal for interactive and chat-based use cases. Gemini's real-time retrieval architecture enables up-to-date factual information but can introduce significant variability in latency due to dependency on live web data retrieval and processing delays. The RTTA variance chart visually depicts the major contributors to latency differences among the models, summarizing the architectural impacts clearly. This visualization helps audiences grasp why Gemini may perform exceptionally well for some tasks and show delays for others, while ChatGPT-4o remains consistently fast due to its streaming approach, and Claude sits in between with reliable but slower RTTA for certain workloads. Workload sensitivity analysis shows that translation and creative tasks generally exhibit higher RTTA variance across models, especially for Gemini, due to its retrieval-heavy approach. Technical queries and multi-stage reasoning tasks exhibit lower variance, as they rely more on internal model capabilities rather than external retrieval. Understanding this sensitivity helps teams align LLM selection with the specific needs and latency requirements of their use cases. The practical implication for deployment is that organizations should align LLM selection with the nature of their tasks and required interaction speeds. For applications requiring fast, consistent interaction, ChatGPT-4o offers clear advantages. For scenarios where the freshness of information is critical, Gemini can provide value despite its latency variability. Claude remains useful for batch processing and scenarios requiring structured, stable outputs where slightly longer latencies are acceptable. Based on our findings, we recommend that teams consider RTTA as a critical factor in LLM selection, particularly in environments where interaction speed directly affects user productivity. Teams should also evaluate the cost-performance trade-offs and be aware of how latency compounds at scale, impacting workflows in enterprise environments. A careful assessment will help balance consistency, speed, and information freshness aligned with business goals. In conclusion, our benchmarking study highlights that RTTA differences, while sometimes small in absolute terms, have significant cumulative impacts on workflows and user satisfaction at scale. Architectural choices such as streaming versus crawling significantly affect these outcomes. As teams continue to adopt LLMs, considering RTTA alongside accuracy and cost will be essential for effective and efficient deployment. Thank you for attending this presentation on benchmarking Claude, ChatGPT-4o, and Gemini for RTTA. For further discussion, collaboration opportunities, or detailed data access, please feel free to contact me at sfabish@comcast.net. Your engagement and questions are welcome as we continue to optimize LLM deployments for practical, real-world scenarios.